Okay, so today we're going to look at annuities. So annuities is an investment. So that means we are an investment. We're putting money into the bank. So we're putting money into the bank. So when we see that, so what we're going to say, we've got some money saved up or whatever we've got. We're going to put it into the bank as an investment. So that means the investment is going to grow and get interest. So it gets this compound interest. So when we have an investment, you might like to put up the top about Finance Solver. When we're using Finance Solver and we're investing our money, that means it's going into the bank. So you're going to have to remember that your PV, when we're on the Finance Solver part, is a negative because it's going into the bank. And we're going to get this compound interest. So this compound interest you're going to see is that R value down here in the recurrence relation. So that's where you're gaining some money. So you're investing it and you're gaining some extra money. Now, sometimes in an annuity, you'll have a payment. Now, if you are making a payment, like you'll take out a payment. So say you've decided to invest all this money, so you've got 100,000 you're investing, it's going to make, but you're going to take out a weekly payment amount every time. So that's what you'll see. So when you see these payments in the regular payment and in Finance Solver, that's going to be a positive payment coming back out to you. So that's if you take the payment out. So that's it. So that's when you're going to use this investment and you're going to slowly take a payment out and you'll use it until it zeroes out. So what it actually does is you're getting a little bit extra for your money because you're getting interest on it as well as taking it out. So that's what's happening. So here's a recurrence relation model. Now remember VO, it should have a VO when you do a recurrence. So you write initial investment amount would be there. So this scenario here is when you are taking out a payment. Sometimes you can get an annuity where you're adding extra more. So that would be an example of that would be when you say superannuation. So your super's built up, you've got this big amount, and then every every fortnight, you are adding another extra payment. So your super, like that big investment, is making money, but you're also adding extra into it on a regular payment. And that you do that too, so when you get to the end of your retirement, your super has grown and it's to an amount that hopefully you can live off. All right, so that's what you've got to be careful. So if you was that different change, if you were adding more to it, then this so you might want to pop in there. So this is underneath, you might say when you're receiving a payment. I might say that. So when receiving a payment, it looks like this. When you're we'll write adding extra payments, it would look like this. You'll see a VN plus 1 equals, it'll be RVO, and it'll be plus D. So you'll see that you'd be adding more to it, all right? So it'll look like that. So it depends on what you're doing, but both cases, you're getting interest on the amount you're making money. All right. Okay, so with this one, it says Reza plans to travel overseas for 6 months. He invests $12,000 in an annuity that earns an interest rate of 6% per annum, compounding, providing him with a monthly income of $2,035 each month for the 6 months. Model this annuity using the recurrence relation form. So they want us to set this up in this format, and we would have that on our summary sheet. So sometimes they might be nice and give it to you there. If they just had set it up in a recurrence relation, there's you have that on your summary finance sheet. Go have a look. It says annuity. All right, so we've got to put the initial value would be the VO. So what he invests, which is 12,000. And then you see we've got to calculate this R value. So if you look over on our notes, our R value was found by going 1 plus the rate divided by PPY over 100. So in this example, it'd be 1 plus the 6% divided by, now because it's monthly, divided by 12 over 100. So you're going to see a number of 1.005. So we know when we write out our recurrence relation formula, that's what my big R value is. Then we write VN. Now this, the D part here is the payment, which is up there and they've told us. So we go that and we're going to minus, because every time he takes out the money, it reduces his balance. So there's a recurrence formula set up for this scenario. With this, Reza's annuity can be modelled with the following recurrence relation, which is good because that's what we worked out. So we're continuing on. And it says where VN is the value of the annuity after N payments received. It says use your calculator to determine recursively the value of the annuity after Reza has received 3 payments from the annuity. So down here, I've started us off, this is A. So into our calculator, we type the 12,000, press enter. And then when you get to this next line, when you press times, it's going to say answer, and then you'll say times the 1.005 and minus 2035. And when you do that, we'll see this first answer come up here. So that's payment number 1. Then you just keep pressing enter. You'll get payment number 2 and then payment number 3. So when it says to find the value of the annuity, so the answer for that would be 645.33. So remember, we're rounding to 2 decimal places because it's the cents. And then the next one, it says B, the annuity is to be fully paid off after 6 months. So it says, has it fully been paid off after 6 months? If not, how much will the last payment have to be? So we're going to go do this on our calculators, and I'll come back to this. Okay, so we went on with this and we went to do the next 2 payments. So we got, this was the 4th one, then we had 2025.76, that was the 5th one, and then the last one we saw 0.88. So we can see when we're working out, so 4, 5, 6. So we see here we've still got 88 cents left. So for this part B, it says how is the annuity fully paid off? If not, how much? So it's no, not paid off. There's 88.88 still in there. So therefore, the last payment will equal the 2,035 plus the 88 cents. So we're going to say the last payment will be 2,035.88. With this exam question, just to let you know, in the exam, question 18 is one of the beginning questions of the finance section. So you are going to expect this one to be very straightforward. So the multi-choice questions they stagger in terms of they get harder as you get to the end. So when you get to the end, you'd be expecting to do more things to get to the answer. With this, you'd be pretty simple. So let's have a look. The value of an annuity after N monthly payments of 555 have been made and can be determined using this recurrence relation. So they've written that out there. The value of the annuity after 5 payments has been made is closest to. So this is simply a case where you're going to type in that quickly in your calculator, your 100,000, press enter, and then do the times 1.0025 minus 555, and you're going to do it 5 times. So someone quickly do that. Okay, so we did that. If we keep doing that, we got 99695, and you press enter, you get 99389 I'm just popping it in here. Okay, so we get down to the 6th one and we find out that it's C. Okay, so with this question, this is question 24. So this is near the end of it, if not the last question. So there's going to be a lot more involved in this question. So may invest in an annuity. So you know it's an annuity, and interest rate of 5.2% per annum. So you can start writing little things above your thing. So for Finance Solver, the annuity would be a negative PV. This would be your I, your interest rate, and compounding monthly is telling me that PPY is 12. The monthly payments are received from the annuity, so they get the annuity, and they've told me the balance of the annuity after 5 years. So they pretty much told me if I had N would have been 5 times 12, this would have been what FV was. And then they said the balance after 10 years, so if I'd done N 10 times 12, this would have been what the FV was. Okay, so the monthly repayment that may receive. So what you need to do is, obviously, this is the question. So you know payment is the question. So what I suggest you do is you write down all the titles of the Finance Solver. So you go through, so we're going to write them all out. So these are all the things we need to fill in Finance Solver. So if we go through our question, we can see that we know I, the interest rate is 5.2. We know that really important to put the question mark, put that on there so you know you don't accidentally put everything, and everything else should be able to be filled in. So I know PPY is 12. Now they're asking me to find the value of the payment. So I must be able to get those other values. Now, if you look at the question, the PV, the initial amount invested was never given. And so what you need to do, but you have been given a section of time. So if you go from year 5 to year 10, how many years is that in here? That's 5 years. So what we're going to do is pretend that this is the start and this is the end. So I'm going to use this as my final value, and I'm going to use this one as my initial value. So what I mean by that is up there in the question, this number here is going to be what I initially invest. So I'm going to pretend I'm investing that. So I put that amount in, which would be a negative. Okay, and then I'm going to say, well, it's going to be 5 years on, so 5 times 12 monthly payments. I'm going to say I end up with a value of that 6992.27. And it's going to be positive because the bank, it's an investment. The bank has to give it back to me. So when you do that, you'll end up, and you press enter on that. So you've filled in all the others. This is now clear. You press enter. You're going to see that it rounds to 1,500. So we'll get that. Okay, so here we can get an amortization table for annuities. So they are, if you have a look, can be very similar to a reducing balance loan because it's similar. You are gaining interest, then you're taking a payment out. So they look very similar. So what you can see is you can see a few points about it. So if you've got this annuity, so you start off with the 12,000. What happens is they're going to give you, for the first payment, you earn $60 of interest. So even though you're taking out 2,035, well, you're not really using all your money, you're using $60 of the interest. So what your loan actually reduces by is this amount here. And that's why they say principal reduction. That's what your amount is going down by. So if you have a look, we've got a few values. So say this value here, that is the balance. So how do we get the balance? So the balance is found by taking the total before and minusing the principal reduction. So say for that example, so e.g., I could have said it would have been 12,000 minus the 1975, and that's how we got, I'll do it down here, sorry. So that's how we got the 10,025. Okay, so then that's that bit. If you were, see how here we haven't found out the interest, we don't know the interest rate, but you can calculate the interest rate. So I'm going to use this interest amount, and I'm going to use this one here. So how you calculate interest, so interest, I'll call it the amount, so that would be a dollar amount. So that's going to be the rate per annum divided by PPY over 100 times the balance before. So say, for example, I was trying to find the interest rate. I could use this, I could say, well, 30/3 equaled the rate over, I'm just going to say 100. So we'll just find out this rate in this table, times the balance before, which would be 6045.33. So then you could always do solve. So this is a really common question for you to be asked, the rate of an amortization table when you can't see it. So this is how you would find that out. So when I find the rate is 0.5%. So here, whatever they're doing, it's 0.5% every period, every whatever. If it was monthly, this would, say this was months. If I'm saying this is months, then this is the monthly rate. Because we don't know, we're just going to assume it was whatever it is, yeah? Okay, so with this one, Joe invests $200,000 in an annuity. So here's where you start going, all right, that's a negative PV, paying 5% compound interest per annum. So that was definitely my I in my finance solver. And compounding monthly, so I know PPY equals 12. He wishes to be paid monthly payments for 10 years. How much will he receive each month? So they're asked for the payment. That's the question. So here I'm going to do A. So I'm going to write out all, this is what you'd be doing on the page, is write them all out on your workout page, whatever. And you'll put them in. Big help is to put the question mark on what you need to know, because then you go, right, I should be able to get everything else. So he invests $200,000. I know that's the PV. The interest rate, I know, is 5. Now, it said PPY, compounding monthly, that's 12. Now, he said it's going to last for 10 years. So I do know it's 10 times 12. And if you're going to use it up after 10 years, he just wants it all to be finished after 10 years. That means the final value would be 0. So you can see I've put that in there, and you can see how I got the payment. I can see it sitting there. You're going to receive a monthly payment of $2,121.31. So there's your payment. In part B, it says if he receives a regular payment of $3,000, how long will the annuity last? So this how long will the annuity last? That's the N is the question. Okay, so when you write out all your little titles, again, sorry, that one's FE and PPY. So just go put, all right, ends the question, so I should have everything else. So the interest rate didn't change, what he invested didn't change, the payment did, and the payment he was receiving a positive 3,000. So remember, and he was still going to pay, we wanted to see how long it lasts, so we'll zero it off, and 12 months, and you can see, you just see there, it says 78.26. We're just going to go to the whole number, don't worry about rounding. So if it was 78.9, still say 78, yeah, because you don't get that full 3,000, do you? We would just chuck it on the last one. So we're just going to say, and just write 78 months, okay? You might say 78 months with the last having extra. Yeah, because it's 0.2, so you definitely was going to have extra. Just so you understand that. And then what they normally do is they'll say how much extra can be added, and we'll work that out. We'll do some examples later on. All right. Okay, so let's do the last one, C. It says, what is the interest rate correct to one decimal place if Joe withdraws 2,500? So interest rate is the question. Okay, so when you write them all out, sorry, NI, PV, payment, FV, and PPY. When you write them all out, make sure you got a question mark on that one. Okay, he's going to do 10 years up there, so 10 times 12, still investing 200,000. Then his payments are going to be, positive 2,500, and he's still going to zero it off, and PPY is 12. And when you did that, it said to one decimal place, so we saw that it was 8.7% is what he would need to get if that scenario was happening. Okay, so with this question, it says the 4 lines of the amortization table in an annuity investment are shown below. The interest rate for the investment remains constant, so that's important, so you know it's not changing. But you have to be really careful here. They are saying the payment may vary. Now, because it's question 23, it's later on in the exam, so you'd be expecting to do something else. So when it says the balance of the investment after payment 20 is 7,500, so we can see that. But they said find the value of payment 20. So obviously this one here is the big question. But what you're going to do, obviously, they've got the 100 there. It obviously isn't that simple. It's not 100 because they also warned you that it may vary. So what you're going to do is you've got to think about how this amortization table is working. Now, this is an example of an investment where they're adding extra. They're not taking out a payment. They're just adding more and more to it. So this is like an example of, say, your superannuation. You've invested your money and you're going to continually keep paying more into it. You want the investment to build up. So you have to take note that this actually says principal addition. Because you're adding more, you're not taking it out. When you're taking it out, it says principal reduction. So in the first, so they've put this amount in, they gain this interest here, say in the first, and they also are putting $100 more in. So the extra is the payment plus the interest. So if we look down here, we need to probably know, we need to be able to work backwards and find out. So what I did is I found out what this principal addition would be. You could find that by using the current balance minus the balance before. So just to show you, I've done it in purple to show you how you got that one. So if I did the current balance there and minus the balance before, I get the principal addition. I find out what happened, how much more was added. So I'm going to do that down here. I'm going to use the 7,000 that I know and minus the balance before. So I know in that in that payment 20 month, in that 20th month, 266.17 was added to this account. So some of it would have been interest. So I need to know how much of that was interest and take that away to know what the payment was. So over here, we just did this before in the notes. We said how we can calculate interest is we get the percentage amount over 100 and times by the balance before. So I just did a little example up here to show you how they got that interest amount of 28 and they used the balance before. Now I'm going to use that to find out what the rate is. So because I don't really know if it's monthly, weekly, who cares? We're just going to say it's 20. So I'm just finding the rate. I'm calling it X, little x, whatever the rate is. And I solve and I find it, and I find that it's 0.4%. Every payment, they're getting 0.4% on the balance before. So that way, I've now used this 0.4 to find out the interest amount. So it's the interest amount here times the balance before, and this is how much interest they got. So to work out the payment, it would have been the payment minus that interest. The total amount that was added minus that interest, and I get the payment, which is why I get answer D. So that was there.